NASA can build rockets. That's never been the problem. So why does the world's most famous space agency pay SpaceX to launch its astronauts? This is not a story about one company replacing another. It's about how the economics of reaching space began to change. SpaceX has carried NASA astronauts to the International Space Station, delivered cargo into orbit, and become one of the agency's most important commercial partners. But that leads to a bigger question. If NASA already knew how to build spacecraft, why did it decide to let a private company help carry humans into space? The answer lies in a problem every space program eventually faces. How do you make space exploration sustainable? Because reaching space once is one thing, doing it again and again is something else entirely. For decades, NASA's approach was straightforward. The agency defined the mission, it designed the spacecraft, and it managed almost every part of the process itself. That model created some of the greatest achievements in exploration. The Apollo program sent humans to the moon. The space shuttle helped build and maintain the International Space Station. Robotic missions explored planets and environments far beyond Earth. But those achievements came with a difficult reality. Space is expensive. A launch involves far more than the rocket itself. Behind every mission are thousands of people, years of engineering, testing, manufacturing, and preparation. And after each mission, much of that effort had to begin again. A new mission often meant a new vehicle, new preparation, and another massive investment. Eventually, NASA faced a different challenge. What happens when space exploration is no longer about one historic mission? What happens when you need to go back, again and again? To make that possible, NASA had to tackle one of the biggest costs in spaceflight, the rocket itself. For a long time, rockets were treated as extremely expensive machines built for a single mission. A rocket would launch, deliver its payload, and most of the hardware would be lost. The next mission meant building another rocket from the beginning. That model was accepted for decades because space was still incredibly difficult. But as humanity looked beyond Earth, that model had a major limitation, and that was the problem SpaceX decided to attack. SpaceX wasn't the first to pursue that goal. NASA had been working on the same challenge for decades. One of its biggest attempts was the Space Shuttle program. The shuttle was built around a simple idea. Instead of creating an entirely new spacecraft for every mission, NASA wanted one that could fly again and again. In many ways, the shuttle was a success. It completed more than 100 missions, helped build the International Space Station, launched satellites, and carried astronauts on some of NASA's most important flights. But reusability alone wasn't enough. After every mission, the shuttle required extensive inspections, repairs, and preparation before it could fly again. The vehicle could be reused, but the process was still complex and expensive. Years later, SpaceX approached the same problem from a different angle. Instead of asking, how can we build a reusable spacecraft? It asked, what if the most valuable part of the rocket could come back and fly again? That concept became central to SpaceX's approach. The challenge was reducing how much hardware was lost after every launch. That led to the development of the Falcon 9 and its reusable first-stage booster. After launching a payload into space, the first stage returned to Earth, landed vertically, and was used again. But making that happen was extremely difficult. The rocket had to survive intense heat and pressure during re-entry. It had to control its movement while falling through the atmosphere. And it had to land with incredible precision. Early attempts failed. Some rockets crashed, some lost control before reaching the landing pad. But every attempt provided new information. Every failure revealed something the previous test hadn't. Eventually, those lessons paid off. In December 2015, SpaceX successfully landed a Falcon 9 first-stage booster after an orbital launch. It was not the first reusable rocket system ever created, but it demonstrated that reusable orbital-class boosters could become part of a practical launch operation. Over the years that followed, SpaceX continued flying and recovering Falcon 9 boosters, Reusability was no longer just an idea being tested. It became a working part of the launch system. For NASA, that was more than a technological achievement. It was a practical solution. And that is what made SpaceX interesting to NASA. As NASA's ambitions grew, the agency faced a different question. What should NASA build itself? And what could commercial companies provide instead? This led to a major shift in NASA's approach. Instead of creating every system internally, NASA started working with commercial companies to provide certain services. NASA would continue leading the missions and setting the requirements, but private companies could develop new technology and provide transportation systems that NASA could use. This became the foundation of NASA's commercial space programs. One of the most important examples of this new approach was NASA's Commercial Crew Program. After the Space Shuttle retired in 2011, the United States no longer had a spacecraft capable of launching astronauts into orbit from American soil. For nearly a decade, NASA relied on Russia's Soyuz spacecraft to reach the International Space Station. To restore that capability, NASA partnered with private companies to develop a new generation of crew transportation systems. SpaceX was one of the companies selected. Through the program, SpaceX developed Crew Dragon, which successfully carried NASA astronauts to the International Space Station in 2020. But the real significance was the new way of working it represented. NASA defined the mission and safety requirements, while SpaceX developed and operated the transportation system. This allowed NASA to focus on ambitious missions beyond low Earth orbit, while SpaceX continued improving the vehicles that made them possible. In the end, this isn't really a story about NASA or SpaceX. It's about how space exploration itself has changed. NASA didn't need SpaceX because it forgot how to reach space. It needed SpaceX because the future of space exploration required a different approach. And that is why NASA needs SpaceX.